Hi guys. The Napiers rule is related with the spherical triangle. In geology, it is used mainly in the crystallography to solve problems related with spherical triangles. And here, that is the stereographic projection of a crystal is given. This is the crystal, and this given thing is the crystallographic projection or stereographic projection. So what happens? The spherical triangle problem is used to solve with this Napier's rule. So this could be taken as a spherical triangle which is given in a stereographic projection. So I will just mark it for you. So this is a spherical triangle which could be marked in a stereographic projection of a crystal. It may be any type of crystal like hexagonal type, cubic type. So here for the instance we have taken the cubic system type of crystal. So this is the sides of a spherical triangle. So there will be 6 angles in a spherical triangle. And there will be a 90 degree. So that is marked here. So about the theory part. So what is Napier's rule? So what is Napier's rule? So in mathematical crystallography, Napier's rule is used to solve some problems related to the crystal angles of spherical triangles, which forms in stereographic projection. Napier's rule is applicable to right-angled spherical triangle. So here a spherical triangle is given below. This is a spherical triangle which is in a crystallographic projection. So in which one of the included angle is a right angle. So this is the right angle which is given here, and there are 6 angles in a spherical triangle. 3 of them which is included angle and 3 of them which are side angles. So that is also given here. 1, 2, 3, 4, 5, 6. So 6 angles are there. Here 1, 3 and 5 are the real angles. That is the side angles, and 4, 6 and 2 are the included angles. The angles are serially numbered from 1 to 6 in anti-clockwise direction starting from 90 degree. So from the 90 degree here, 1, 2, 3, 4, 5 and 6 that are marked in an anti-clockwise direction. So this is the anti-clockwise direction in which it is marked. So now getting into the problem solving part, Napier's theorem states that the sine of the middle part is equal to the product of the tangent of the adjacent part or to the product of the cosine of the opposite part. So this is the thing that you have to keep in mind. So here, in order to apply Napier's rule and to understand what are the middle, adjacent and opposite part, it is necessary to construct a starfish diagram. So it is constructed below in this manner. So what we have to take a note, that first thing that we have to construct in a problem in a Napier's rule is a starfish diagram. So here this is the LHS, that is left hand, this is the RHS, right hand side. So the left hand side and right hand side. So the 90 degrees also given. So this is a spherical triangle. For instance, I am just drawing. And what happens? The angles would be given in a particular way. It will be different in different questions. So we have to look how it is given and mark in that way. So here this is the 90 degree given, and from there we have to go in an anti-clockwise, that is 2. Then it comes 3, then it is 4, then 5, and then the side angle which comes as 6. So in that manner we have to mark what? The starfish diagram in that order. So 90 degree will be marked here, and the 2 in an anti-clockwise here, and the 3. So what we have to keep in mind, that in the LHS it should be 90 minus the particular angle. In the arches as such we can add whatever thing is there, as that we can add. So in LHS it is 90 minus the particular angle, and in arches as the angle as it is. So here it is given as the opposite part is given, we have to use what? The cosine equation, and if adjacent part is given we have to use the tangent equation. So that's the thing. Now we could solve a problem. So a problem is given for a crystal of zircon 100 interfacial angle 111 is given as 61 degree 40 minutes, and we have to calculate 001 interfacial angle 011. So let us look how it is constructed or how it is solved. As our theory part is completed explaining, so we are getting into the practical application of this Napier's rule. So first thing we have to draw is the crystallographic projection of this particular crystal. So a part of the stereographic projection of the zircon crystal is given. As we can see, it is 100111. It is a part of a cubic crystal, as because of the zone symbols that is given in the question. So we could mark what all are the zone symbols here. That is 011, 100, 010. So this we have to memorize as we are studying the stereographic projection. So now what is the thing? We have to construct this line in between, because the given thing in the question, there is 111. So it could be only marked by constructing this kinds of line. Now we are constructing it and we are marking 110 here. So we could get this 1011 and 110 as because we have to calculate this interfacial angle between these two zone symbols. So we have to construct it. So we are constructing it, and then by adding these two, that is 010 and 001, we will get 011. In that same manner we will get other two sides zone symbol. In the same manner 001 and 100 could be added, and we could get the angle, the zone symbol as 101, but that is not needed because for the sake of the question we don't need that 101, and this kind of construction of that line is also not needed. So our part of the crystallographic projection or stereographic projection is completed. So now what we have to do is that apply or given what all are given we have to look. So 100 interfacial angle 111 is given, that is 61 degree 40 minutes. So first we have to mark that where will this 61 degree 40 minutes will come. So it will come between these 2 points, these two zone angles, 61 degree 40 minutes will come. So for the sake of the question, this particular triangle is taken, and this part could be given as this 60 degree 40 minutes minus 90 degree. So we will get interfacial angle between 011 and 111. So we are just writing it here. Interfacial angle between 111 and 011 is equal to 90 degree minus 61 degree 40 minutes. That is given here as I had explained before. So it is written here 40 minutes, and the answer we will get by calculating is 28 degree 20 minutes. So we have gotten the answer. So in this part we got the angle as 28 degree 20 minutes. So now what we have to do is that we have to construct a starfish diagram for further calculations. And here the given angle is 90 degree, and this is actually 90 degree also. So from here we are going to construct the starfish diagram, keeping all this data we have obtained in our mind. So our prime vision is to find the interfacial angle between 011 and 011. Sorry, 001 and 011. So we have constructed the starfish diagram. Here it is given as 90 degree. So we can start our thing. So 90 degrees marked, and then we have to go in a anti-clockwise direction. So from here, this side, this angle, it is unknown. That is the angle that we have to calculate. So it is given as theta. So we are giving it as theta. So the next angle, that is 90 minus 45 degree, because the line is dissecting or dividing it in equal half. So it is 90 minus 45 degree, and also we have to keep in mind that in LHS side, that is right hand side, it is always 90 minus the given angle. So it is 90 minus 45 is given. So the next two angles that is unknown for us. We don't know what it is. So what we have to do? We don't have to put anything there. Just leave that two spaces. Then the angle that we have find, that is 90 minus the given angle. So that we got as 28 degree 20 minutes. We have to write that here. So we have constructed and successfully marked all the angles. So the next step is very simple. So the theta, sine of theta, middle part is equal to opposite or adjacent, product of opposite or adjacent side. So the thing given here that we have in our hand is the what? Adjacent side of the theta. So we have to use what equation? We have to use the tangent equation. So sine of middle part, sine theta is equal to product of the tangent of the adjacent part. So tan of 45 degree into tan of 28 degree 20 minutes. So by calculating, we will get the tan of 45 degree as 1 and the tan of 28 degree 20 minutes as 0.33. I just forgot to add the tan for 28 degree 20 minutes. Sorry. So we will get the answer as 32 degree 37 minutes. That is theta, we will get something as 1 into 0.33, and sine inverse we will get it as the theta is equal to 32 degree 37 minutes. So that is the answer. That is how we will solve the Napier's rule.